Okay, as promised, a video on vectors or parametric. They're almost identical. It's almost just a difference in notation. So in this problem, we have an object moving in the xy plane. Again, parametric motion versus straight line motion. And we're given the velocity vector. V of t is equal to cosine t cubed and 3 sine t squared. So at t equals 2, you always have to have a starting point. The object is at 4, 5. So that's giving you some more information. So first question, just testing your knowledge about tangent lines, is what's the tangent line at the point 4, 5? Well, how do we get tangent lines? We calculate the slope of the curve. And the slope of the curve is dy dx, which is dy dt over dx dt. So at 4, 5, that's t equals 2, I plug in 3 sine 2 squared. Remember, this is dy dt here. And cosine 2 cubed, I get 15.604, 3 decimal places. And therefore, my tangent line is y minus 5 equals the slope times x minus 4. Now, those of you who love to do your mx plus b, get rid of it. This, you can't make a mistake, and this is perfect form for the AP. All right, second, what is the total distance traveled from 0 to 1? So today we talked about arc length, but I'm going to talk in a little bit more detail here. The arc length formula is the square root of dx dt squared plus dy dt squared dt. So we talked about that today. So if I integrate that from 0 to 1, I get 1.458 using FNInt, which you should practice till you can do it very quickly and efficiently. But I want to talk about this also. If we go back to straight line motion, if we integrated velocity, we got displacement. If we integrated the absolute value of velocity or speed, we got distance. Well, besides this being the arc length, this is the velocity vector's magnitude, which is speed. So I'm integrating speed over time. I'm going to get distance. All right, I hope that helps. Now, last question. What is the position at t equals 3? So ignore this right here. The integral from 2 to 3 of, this is the velocity vector in the x direction, cosine t cubed dt. That tells me how far it has gone, the displacement in the horizontal direction. I write here x of 2. All I mean by that is, if I want to know where it is at 3, the starting point is at 2, which is 4, and then I integrate from 2 to 3 the velocity vector, and I get the total there. So the same thing, where is the y coordinate at 3? I say I integrate from 2 to 3 the velocity vector in the y direction dt, but I add that to where was it at 2. So the final position is 3.953, 4.906. So in review, vectors, parametric, the same concepts. You're now dealing with motion in the plane rather than on a straight line, but not that much more difficult. So again, I'd like you on this one, recognize this is the arc length, which gives me the distance, but you can also think of this as speed, because the speed is the magnitude of the velocity vector, which is the square root of this squared plus that squared. All right, see you tomorrow. Got any questions? Let me know.